Good afternoon, everyone. On behalf of agricultureinformation.com, I welcome Mr. Gagan Deep, and he will speak on the topic solar powered cold storage and ripening chambers. I now request the speaker to begin. Thank you.
Yeah, thank you, Lakshmi. This is Gagan. I'm from Frozenhive. I should introduce myself. Uh, so we are a startup company established at around 2019, and our core focus has been on developing cooling solutions which are energy efficient. So energy efficient cooling solutions invariably becomes a system which can also be powered by a solar system. Uh, So our main focus has been to develop cold storage solutions for a rural market, where, of course, the electricity in rural market is uh, having a lot of challenges. Either it's intermittent, uh, where there is a scheduled load shedding. Probably they have electricity for like 4 to 6 hours per day, and the rest of the day there is scheduled load shedding. Or there could be due to grid failures, maybe because of heavy rain or poor infrastructure. There could be a long stretch of days where there is no electricity at all. Um, so a solar cold room for this kind of scenarios makes it very ideal. So having a decentralized cold room right next to your farm, which has little to minimal dependency on the grid power or infrastructure itself, uh, gives enormous freedom for the farmers. They don't have to travel to centralized cold rooms, which oftentimes are at a location which might increase the overall cost, transit cost of the material itself. So this kind of unit can be placed right next to the farm. It's energy efficient, meaning it can be powered by solar power or or a partial irregular grid energy system is also sufficient, to power such a kind of cold room system. So at the core of this technology, it's like what the vision that we have is to have multiple rooms uh, at at the site of farming, right? It's like you have multiple rooms. Why do we want multiple rooms is basically a particular area might have multiple produce. It's like you might have some vegetables which you want to store it in a cold storage. Meanwhile, you might have another farm wherein you're growing bananas or anything like that, which you want to ripen it. So each of this material needs to be handled in its specific way. So if you have multiple rooms, that gives you this opportunity to not just get locked into one single produce, but uh, have uh, have uh, usage for your cold room throughout the year. Irrespective of the season, it's like you could probably store milk in one of the room at 0 degree, and simultaneously probably use the other room for ripening of bananas at 16 to 20 degrees Celsius. So that kind of flexibility you will be getting. And the other USP is we have a two-stage cooling system. The first stage of the cooling is basically, I will just try to turn on my pointer. Um, is on the upper half. We have integrated a cooling tower. It's basically the first level of cooling is happening due to the evaporation of the water itself. It's like the coolers that you might be using in your rooms, right? It's like there is no compressor, but due to the evaporation of the water itself, there is a reduction in the ambient temperature. So if your ambient temperature is around 45 degrees, the first stage of cooling is bringing down the temperature to around 22 23 degrees. So the major heavy lifting is done by the evaporation. This makes the whole cooling process very efficient. And this new ambient temperature is what becomes the heat rejection temperature for the next cooling stage, which is done by the chiller system, which is again a vapor compressor kind of system. So this kind of architecture gives you a phenomenal COP. It's like the efficiency is around 6 COP, right? It's like if you look at most of the cold storages, uh, it's like if you compare from similar compressor technology cold storages, it's like they might be probably giving you somewhere around 2.5 to 3. COP at best. But we are here doubling it down. It's like as soon as you improve the efficiency, then the investment that you would have to do on the solar panels would drastically be cut down, making it a very affordable solution. Yeah, right. Uh, and this comes with a backup. It's like it's a backup which doesn't use batteries. It's like if you want to have a completely solar cold room wherein you are having sunlight for just 8 hours in a day, and remaining 16 hours there is no sunlight. So how do you keep the rooms cool? So you need some kind of energy storage device which ensures the temperature is maintained throughout the day, right? In our case, we are using phase change materials. Basically, it's like we have a separate tank. Inside the tank, around 2,000 kgs of water gets turned into ice during the day cycle, and as it goes into the night cycle, the melt water is again circulated in the rooms to maintain the temperature. So this again eliminates the complete need of batteries to store energy, but uh, you have a completely cyclic energy storage, which is basically water to ice and ice to water in that kind of system. And our latest rooms are also portable in nature. That is, uh, let's say you are a tomato farmers. It's like you are probably having a season for like 1 or 2 months. That is your harvest time, right? And rest of the time there is no demand for cold storage at that particular location. You want to move it to the next village. That is also possible. It's like our portable cold room designs can be packed and unpacked in within hours. It's like you can, and once unpacked, you can load all the material into a small three-wheeler, right? A commercial chota hathi or any regular three-wheeler that you get to carry goods. You can pack this all in one single unit like that and move it to the next location. So at the heart of it, this is our cooling unit. It's basically a cooling tower integrated chiller system, which has huge energy efficiencies compared to the other cooling units available in the market. Uh, it's a it has its inbuilt intelligence in it. It's like which ensures that the whole unit never goes into any catastrophic failure. It's like we are able to predict if there is any failure or maintenance required, which is actually a key challenge for remote areas. It's like you cannot afford to have your compressors or cooling unit uh, malfunction, and then we send our support teams to repair it, because reaching the remote location itself is a challenge in India, right? It's like if there is a um, if there is a precursor, or if we know that a thing need if we know that our unit needs servicing well before in advance, probably 2 to 3 weeks before in advance, before there is any failure in the machine, that would be fantastic. And this kind of intelligence is actually built in our system so that there is a early warning for the customer as well for our company to send in required support at your site, so that the cold room doesn't malfunction at large, right? Which means your produce will always be safe, keeping it in our cold room. That is it. These are our regular solar cold rooms with multiple rooms. Each room can, again, as I highlighted before, can be controlled with a specific temperature. And here is the portable cold room. I will come to this in detail in the later slides. This is a waterproof, insulated cold room. If you have a shed or processing unit which is already well protected, uh, we can have this kind of room set up at your location at almost a fraction of the cost of this in comparison to the conventional sandwich panel cold rooms. So, yeah, and one more benefit that I want to highlight about multiple rooms is if it's like these multiple rooms are again powered by one single cooling unit. Having a multiple room gives opportunity wherein multiple farmers can come together to own a single unit, right? If if a particular location has crunch in initial putting in initial investments, probably FPOs can come in where multiple farmers would be using it. They have their own independent rooms, so there is that kind of freedom of storing and keeping whatever you want, and how it's like having your own hygiene inside one single room, right? And which is isolated from the other user. Yeah. So this is little heavy on the technical aspect of it, like how does it function, right? It's like why I would want to still explain this to you is because this is the core of our technology, which gives us freedom to have flexible cold room designs, right? It's like it's like a cold room design is done to tailor specific farmers' need. It's like we cannot have a generic solution and then uh, push it on to every single farmer and hope it works for them. That doesn't work out. It's like some might want it completely solar powered, some might want it to be on grid, right? If there is already grid electricity available at a subsidized rate, why would they want to have solar panels, right? Because that would increase the investment. So, and some locations might want it to be on grid, but when there is power outages or on emergency cases, instead of going on to the generators, they might want a solar backup. So there are multiple use cases, and this architecture allows us to tweak designs in such a way that it very well suits to your niche requirement. So this part of it, which I already explained, the top half is basically the cooling tower reduces the water temperature, which is used to cool the condenser side of the chiller unit. And the chiller unit basically has just two inlet and outlet ports, right? It's a fluid. It's a coolant fluid which is flowing in multiple rooms, right? And each room we are able to control how much coolant fluid has to flow through this depending on the room temperature requirement. If you can see here, there are three rooms that I've shown. It's like basically, let's say, one of the room you want to keep it closed. There is not much material available, and then one of the room here you are maintaining it at 16 degrees. Probably a ripening event. Banana ripening is usually done at around 20 degrees, right? You want to maintain this room at 16, and let's say you have fruits, right? Also apples, which you want to store it at 0 degrees. So it's perfectly possible with one single unit. You're able to maintain this room at 2 and this room at 16, and also turn off the other rooms which are not in use. Uh, that is the beauty of this architecture. And coming to the energy storage system, once the cooling is done, right? If there is once these temperatures are reached, what we do is we keep the compressor running, right? And then we start generating ice in a separate storage unit. It's like this can be designed, the ice tank can be designed or sized in such a way that whatever is your backup requirement, we could accommodate to that. It's like, for example, if you want to have your cold room purely on solar, probably would need a 16 hours backup, because on the next day there is again sunlight. Uh, and so we would have a 16-hour backup in that case. But if you are trying to have a backup because of mm, unforeseen power outages, maybe due to heavy rain, there is frequent power cuts, which is often observed in rural areas. You can have a much larger energy backup system also given. Basically, that gives you considerable amount of time. Probably in this design, it's like 48 hours. It's like, which is 2 days. You know that your temperatures are going to be sustained for next 2 days without using any generators. Why that is important? Because generators are, again, it's even more expensive to run a cold room on generator because it's running on diesel, and today's diesel prices are actually increasing, right, day by day. So that would drastically increase your operation cost. So So this is the explanation of it, and you need not worry about all the details because we have an inbuilt intelligence built into the system, which is going to take care all of this right at the back end. And if and if there is any servicing that needs to be done, if there is any problem that's going to happen, we are able to predict in advance and alert the customers so that we could send in our service team at any location, even before the system actually goes bad. So this architecture opens up a lot of opportunities, right? This could be for dealers. It's like the unit could actually be pushed as a cold room units, and also if you are looking for multi-room ACs, right? It's like one of the major challenges of having solar cold rooms is of low volumes in the market. It's like uh, and then low volumes inadvertently makes any product uh, inaccessible to the common consumer. So this design we are able to also have it for office spaces wherein there are multiple ACs, and instead of having one single DX kind of arrangement, you have a centralized cooling unit, and this powers all the ACs, like which can be expanded up to 5 units, right? So that is one thing. And if you want to rent out a cold room, it's like oftentimes the current architecture wherein you have huge rooms, right? It's like cold room rental storage is basically massive infrastructure. It's like there is a lot of investment that goes into, and you have one single room of large spaces which is dedicated for a specific material. If you want to have a potato cold storage, there's a separate potato cold storage. But what happens during off season? There is no demand, so all this infrastructure is probably just working for 4 to 5 months throughout the year, and rest of the time it's empty, which makes it very inefficient to run cold room businesses. So if you're planning to have a rental business, this architecture gives you that freedom. You have multiple rooms, smaller rooms. It can be rented out to independent customers. It's like you can have it for multiple commodities throughout the year, right? There is no mixing, or there is no smell of one commodity getting onto the other commodity, which is often observed in a lot of cold rooms in India, right? And of course, the portable cold room is again there. Uh, so it's like based on season, you want to have a system which can be moved across the state, right? That is also possible. Yes, and this probably I will skip this. It's basically comparing our solutions with other solutions which are available in the market. It's like there are couple of companies, right? It's like who are specializing on just uh, purely solar-based solutions, and then there are larger cold rooms, larger companies like Blue Star and Danfoss, who are like who their main focus is on completely grid solutions. But one thing that we have been experiencing is most of the rural areas are slowly getting electricity. Maybe not good electricity connection, but there is some kind of electricity. So a solution which could leverage these realities is what we are providing, and this makes it very cost effective and more reliable than going with purely solar solutions. That saying, I'm not saying our systems are not compatible with purely solar systems. It is we can also make our system completely solar powered, but I would still recommend to go with a solution which can be integrated with grid as well as solar power, because seasons cannot be predicted well, right? It's like sometimes it could be cloudy for a couple of days. We have a whole monsoon season wherein like couple of months it's raining throughout this month, and there might not be sufficient uh, solar power available, right? But in this cases, it could switch to the grid systems. So this is the system how it looks. It's like the system is It's built in a very robust manner and easy to understand and install, so that uh, local technicians or with a minimal training to the farmers themselves, they should be able to fix it, fix minor issues that might arise, or the minor servicing. It's possible to do it. It just has two pipes, inlet and outlet. This pipes carry chilled water into the rooms. That is what keeps the rooms cool. And the whole electronics, is built in such a way that you don't have to actively control any of the things in the room. It's like once you set the temperature of a room, the rest of the thing is managed by the system electronics itself. And it is also able to predict uh, servicing required, right? If there is any major failure that might occur, maybe uh, usually that happens. It's like in compressors, if the fan is not working, then the condensers become hot, and then we have seen compressors, cracking because of high pressures and leakage. So the whole system is designed in such a way that there is no catastrophic failure as such. It's able to predict that things are not working as expected. It needs to be serviced immediately, and uh, and subsequent alerts are given. If you want it to be given on your app or mobile phone, that's also possible. Um, so it's so when to service it, right? And there is enough time for you to act upon it. Now, coming to this is how this is the portable cold room. It has a metal structure with insulated, flexible panels. Unlike the regular cold rooms, which has sandwich panels, which are rigid, this is a flexible panels. Yeah, the whole thing can be set up in within hours. Right? You can see it's like it doesn't take it just takes like two people to set up the whole cold room, and then. And then it's up and running within 2 hours. And once your season is done, it's like you don't have any use for the cold room at that location. You can again unpack it, and all once unpacked, it can all fit into one single small commercial vehicle like three-wheeler, uh, AS, Tata AS, Magic, that kind of transport vehicles. You can pack it all into that goods auto and take it into a new location wherever you want. So our technologies are patented. Of course, we are one of the best in class in terms of energy efficiency uh, when it comes to cold storage. We have our test facilities. Majority of the produce is done in house, right? It's done in India, a make in India company. And we have been running this units multiple places. We started out in Pune, and now we have a couple of installations in MP, and now we are setting up more installations in Bihar region, specifically. Right, our customers have are we have a wide range of customers too. It's like milk produce, fruits, ripening, and also fisheries. Right, it's like And yes, this is about our team. We are actually IIT graduates. It's like my friend Nagarjun. He's from IIT Mandi, and I myself from NIT Karnataka. Our our passion for engineering has always been there, and then we are coming up with newer innovative solutions. And through this course of last probably since the inception in 2019, it's like that's almost 7 years. We have been innovating and refining our product, and in last couple of years we have actually got considerable success in terms of performance, which our customers can actually vouch for it. So that is it about the company. If anybody has any questions, it's you could please ask me.
Okay. Thank you, sir, for your
Yeah.
presentation. I'll take up the questions now. In the meantime, yeah, yeah, and move on to the
Yeah.
questions now. What inspired you to develop solar power, cold storage, and ripening solutions for agriculture sector?
Yeah. So the thing is, it's like the main uh, way. It's like I wanted to increase income for the farmers, right? And the easiest way for a farmer to get a better income with whatever produce that he is already doing is to give a better price for his own produce. And the problem is, um, during harvesting, almost all the farmers in a specific location is harvesting at the same time, and then suddenly there is a surplus of the same material, and once there is a surplus, there is a drop in the price. So cold rooms are so essential to stagger this surplus in the market, to have a consistent flow of produce coming into the market. So this becomes a crucial or almost very important part to increase farmers' income. So, so that's why I wanted to build a cold room, which could be a solution for our Indian farmers. But the problem is, cold rooms are energy intensive, and so the next thought is, it's like if there is no grid electricity, then what do you do? Solar energy. But if you directly push the existing solution into solar systems, then the overall cold rooms becomes very costly. So it is very important to make the cooling itself very energy efficient before you start integrating with the solar systems. So that's how our journey has been.
Okay.
Yeah.
What are major
Uh,
challenges faced by farmers?
I lost your question. Could you please repeat that again?
What are the major challenges uh, faced by farmers due to inadequate cold storage facilities?
It's like if I will just repeat your question because it's like your voice was breaking. What are the major challenges faced by farmers in terms of cold storage? Is that the question?
Yeah, because of inadequate cold storage facilities.
Uh,
Got
is
my
that your
point?
question? No, actually, your voice is breaking. So if you could, it's like, did I get your question right? It's like, what are the major
Shall I
challenges?
repeat it?
Yes, yes,
I will.
please.
I will
Yeah,
just
please
paste
repeat
it.
it. Yeah,
I
please
will
repeat it.
just paste it in the chat window. Yeah,
Sure, sure. Yeah.
just a minute.
What are the major challenges faced by farmers due to inadequate cold storage facilities? Yeah, so the the most obvious challenges is basically any produce. If you take, it's like it could be a fisheries produce or it could be fruits or vegetables. It's like most of the markets start off early in the morning, right? It's like maybe even before the sunrise. Uh, but as the day proceeds, it's like because of the temperature itself, even within one single day, the produce starts losing its value because of quality deterioration, right? Oftentimes, it's like if you're not able to sell your vegetables or any fruits, and it's kept out open in the sun, it could lose almost half of its value within one day if the climate is very hot, right? So we with cold room we are able to preserve value, right? Not just for day, but even for months.
Okay. Um, how do solar power ripening chambers ensure uniform and safe ripening of fruits?
Yeah. So the solar power, basically, why we want to have a solar power is because the grid electricity is inconsistent, right? or maybe the grid electricity is unreliable in rural areas. So we want to have a much more reliable source of energy to power your cold storages. That is where either you can opt for a solar panel, which is dependent on the sunlight, or you can have a diesel generator as a backup. This two can be used as whichever you would prefer. But why is it preferable to have solar panels? Is because uh, your operational cost, it's like your running cost throughout the year is substantially lower when you use a solar panel. But and this kind of benefit you wouldn't be getting if you would run it on a generator or any other source. So solar panel gives you a very reliable energy source at an affordable price. So that's what makes ripening systems based on this kind of technology very viable for Indian market.
Okay. What what technologies are used to maintain temperature consistency during cloudy weather or night times?
So yeah, that's a good question. It's like in our system, we have an option where we can also connect it with the grid, right? It's like you can always have a regular grid power supply as a backup. During cloudy times, if there is not enough power being generated by the solar panels, it will automatically switch to the grid electricity. So that is taken care of. And moreover, we also give a backup, right? It's like we can also give a backup up to couple of days also, a thermal storage backup. Basically, even if there is no sunlight for 1 or 2 days, it might not even switch to grid. It could still be running on backup, and then once when there is like sunlight back, uh, the system is again generating energy. Yeah.
Okay. What role do IoT sensor or remote monitoring play in your cold storage solutions?
Yeah, it plays a vital role. It's like the main one of the main challenges of having cold rooms in remote location is serviceability. It's like a cold room needs to be serviced. It's like even your house AC, right? It's like most of us service it once a year. It's like we have to clean the fans. It's like it's like if you do not maintain it as intended, then over a period of time there would be slow deterioration of performance and efficiency. Uh, the IoT system and the sensors or the intelligence system that has been built into our system is able to predict if it's like predict if there is any variation from its ideal performance range, right? This it is able to predict failures even before it is occurring in the system. So there is ample amount of time for us to plan maintenance, and if you want to book a service engineer who would come to your site and take a look at it and fix it, that is also possible. And all this is happening even before the cold room uh, is actually the cold room fails or anything like that. It's like your cold rooms are still running and we are already planning its service cycle. So this kind of advantage is what you get from the IoTs.
Okay.
Yeah.
What reduction in post-harvest losses have you observed after implementing these systems?
One thing is, if it's like if you are looking at the produce that is just thrown away as a complete waste, right? That is around 18%. But the bigger picture is actually the value. Uh, Many a times a produce loses a certain amount of value, so a farmer goes into panic selling. He probably sells it at half the rate in compared to when it was fresh or of good quality, right? Uh, so if you actually look at the value, that's huge. It's around 40 to 50% of value we are able to add to our farmers for using cold rolls.
Okay.
Yeah.
I'll move on to the next question.
Mhm.
Can farmer producer organizations effectively adapt this technology? If yes, how?
Yes. Uh, this system is actually designed for FPOs, or multiple farmers come together and they own this cold room. If you remember, I highlighted about having multiple rooms, right? Powered by one single cooling unit. This brings down the overall investment drastically. And since there are multiple rooms and each room has its own independent control, and there is this self of independence, right? It's like whatever you want to store in your room, there is no cross contamination between other produce. So you feel it's like, for an end user, he's still owning his own cold room. And this is powered by one single system. So for FPOs where there are multiple farmers under them, uh, it's easy for them to rent out, uh, rent out individual room to a specific customer, right? Our company is actually running rental models in Pune. We have a couple of cold rooms which is built right next to mandi, sabji mandi, right? It's like, and and rooms are rented out to a lot of customers on monthly basis, and we actually hand over the key to the customer. They are free to use it at their time and their temperature, and there are no other hidden charges in this kind of rental model. It's like we charge one fixed rent on a monthly basis, and it's like, and the customers are free to change the material as many number of times they want to throughout a month. It's like, as soon as the market opens, if they want to display a couple of trays in the market for 10 trays, they take it out, they display, they're able to sell 6 or 7, and then the rest of the lot they want to bring it back. That's possible. So this kind of flexibility we are able to build in. So it's very well suited for FPOs.
Okay. What is the
Yeah.
approximate investment required for setting up a solar power cold storage unit?
See, it's like, rather than giving one specific value, it's like it is very important to understand what is your need, right? It's like, if you want to have a cold room which is 50 metric tons capacity, of course the prices would vary. So I would give you a range. It's like, our smallest cold room is around 5 metric ton, and that costs around 6 lakh rupees, right? And then and then as and when, how you want your capacity to be, and what kind of, how many number of rooms you want, or what kind of features you want to be added into the cold room, accordingly prices would vary. So yeah, so it's better to actually look at case to case basis. If there is any specific requirement of, this is the capacity that you want to have, this is the number of rooms that you would want to have, probably then you could arrive at a pricing which would be more appropriate. But to answer your question, we start at around 6 lakhs for a 5 metric ton storage.
Okay.
Yeah.
We'll take up the next question. Are there any government subsidies or schemes available for supporting adoption?
Yes, at the user end,
You
there
got
are
it?
a lot of subsidies. Yes, yes, I did. Yeah, you're able to hear me, right?
Yeah. Please proceed.
So on the user side, yeah,
Mr.
there is a lot
Gagan?
of
Yeah,
yes.
please proceed.
Hello. Yeah. Can you hear me now?
Yeah, yeah, I
Hello.
can hear you. Please proceed.
Yeah, yeah. So
Yes,
on the
yes,
user
please
side, there are
proceed.
definitely, yes, on the user side, there are definitely subsidies available. So we advise the customers to go to the local horticultural board and ask what is the subsidy available in their location. So subsidies are varying from one location to another location. So uh, as in terms of manufacturers, we as a manufacturers, there is no subsidies at our end, but uh, customers are able to avail it after purchasing the cold room.
Okay. How scalable are these solutions for rural and remote areas with unreliable electricity supply?
Yes, I think this one we have answered. It's like uh, the main goal of the system is to target such kind of locations where electricity is unreliable. Um, we give a solar powered. Along with solar power, there is also a cooling backup system. Basically, even if there is no sunlight for 2 days, we are able to maintain the temperature due to the thermal energy device that we have in our system, right? So it's definitely scalable for rural market. In fact, it is actually specifically designed for this kind of scenarios.
Okay. Which crops, fruits, or vegetables benefit the most from solar powered cold storage and ripening chambers?
Well, there is it's like Yeah, I can tell you instead of giving you a complete global picture, which I might not be the right person to answer also, right? We have had considerable profits observed among banana ripening farmers, right? The quality of bananas was exceptional when done through this kind of system, and banana ripening chambers inherently need multiple rooms. And we have also seen a lot of repeat customers from shrimps. Most of this Odisha belt where during shrimp harvest, it's like the temperature becomes more than 45, 46 degrees, right? So they're not, it's like once harvested, it is not even lasting for few hours before the reefer van comes and picks up this produce, and then puts it into their cold storage vans. So in this kind of cases, it's almost an essential part. It's like to have a business like this, you actually need a cold room. It's like fisheries. It's like where produce is perishable, right? Uh, it perishes within hours. Actually, even vegetables do perish, but but maybe because of reluctance, or maybe there is the cost to return kind of benefit is little on the lower side for vegetables. We haven't seen a lot of traction for vegetables, but I would still recommend to keep the vegetables also in the cold room, because that is what is observed in most of the developed countries. If you go to Europe, China, it's like or US, it's like where the infrastructure is very well developed, they even keep the vegetables in cold rooms. It's like that would help you retain, value throughout the day. It's not like long storage for vegetables, right? It's for a day to day basis storage itself. It's like it would preserve the freshness, right? For now, as of now, we probably sprinkle um, water on the gunny bags or something like to keep the vegetables moist, or the leafy vegetables moist throughout the day. It's in a way, it's like if you look at the heart of our technology, we have a cooling tower. The system, the first level of cooling is done by water, which is evaporating. And then there is a second level of chiller unit, which keeps the room cool. So having cold rooms for any fruits, vegetables, and fisheries would definitely be a profitable system.
Okay. What were the biggest challenges you faced while building frozen knives?
The biggest challenge is we being a manufacturing and research heavy company, right? It's like it was built completely on my own savings. So having a manufacturing company starting from scratch to the where we are right now, it is very capital intensive. It's like company which is just starting, it's like probably you want to get loans. It's like loans would be very risky. To find investors who would come in and help us develop the technology itself is little challenging. But anyway, God's grace, we were able to do it with our savings. So now we have we are seeing good support from the ecosystem.
Okay. If farmer has only 2 to 5 acres of land, what would be your recommendation for accessing cold storage economically?
It's like if you could little elaborate on what exactly is he growing in this land.
That is not mentioned, sir. You can
Okay,
just
okay. These are
tell
all
in general.
okay. In general, then again, it's like if you feel um, a, a lot of investment is a risky bet for you. What we always recommend is it's like for small landholding farmers, they could come together with multiple farmers, right? It's like usually if you take any specific village, there would be milk that is throughout the year, which is being done, and then there would be seasonal crops, right? So we could always have a solution, even if a cold room is as small as 5 or 10 metric ton. We divide it into 3 rooms. Uh, it's like we can make it viable. It's like right, but as such, there is no hard rule like this much acre of land. This is the size of cold room that you would need. There is no such relation. You would need more details about what you are growing and what is your strategy. It's like you want to store this produce for a couple of days. That is basically to aid your logistics, right? Taking it from your place to another farm. Uh, Selling point, you want to do it every couple of days, so you only want to accumulate the storage for next 3 4 days, something like that. Then probably you would need a smaller cold room. But if you want to have a complete long-term cold storage kind of plan wherein you want to hold this whole produce probably for ginger or lemon and sell it at a point when the price is much more better in the market, probably would need a larger cold room.
Okay. What advice would you give to young entrepreneurs interested in developing climate smart agricultural technologies?
Advice would be to actually meet as many farmers as possible before we come up with a solution, right? It's like it's very important to be in touch with their ground problems uh, rather than having a solution being built just at the R&D centers, right? It's like that would give us a better understanding. That's how we understood that it's not the building of the cold storage that is the challenge. It's about ensuring how the cold room is running after installation. Even after 4 or 5 years down the line, it's like people have spent their hard-earned money. It's like which is in lakhs. Sometimes it can go up to crores. So you want the system to be running and profitable. How do you do that? It's like that is a bigger challenge rather than building cold rooms one after the other.
Okay. Thank you very much, sir. We have completed the round of questions. On behalf of agricultureinformation.com,
Mm.
we would like to thank
Yes. Thank you.
Mr.
Thank you.
Gagan Deep for the talk.
Yes. Thank you very much. Yeah. Bye bye.
Bye-bye.